Write on the topic heat and temperature. Thermal properties of matter. Okay, listen. So what do you understand by the term heat and temperature? Heat ante వేడియా, then temperature ante tell. Which one? Okay, tell me the first thing, like is both are same or different? Then what is the difference? Heat heat ante heat, temperature ante temperature. Nice. So heat is nothing but it's a form of energy. It is a form of energy, and we'll study about heat in calorimeters. Okay, we'll study about heat in the calorimeters we'll say. So temperature is nothing but it's a measurement of heat. It is the measurement of heat. Heat is a form of energy, and we'll study about that heat in calorimeter. Okay, in this topic only, like thermal properties of matter. Now we'll go into the topic temperature. Temperature is nothing but measurement of heat which is contained in the body, So simply we can say it is nothing but degree of hotness or coldness. Degree of hotness or coldness. So what is the device we are using to measure the temperature? Thermometer. So the device used to measure the temperature is thermometer. The next point is the SI unit of temperature is Kelvin. SI unit of temperature is Kelvin. The next point, there are many device used to measure the temperature, like Celsius, Fahrenheit and Kelvin. Okay, Celsius, Fahrenheit and Kelvin. So in this Kelvin is only the SI unit. Next point, for every scale of temperature, for every scale of temperature, for every scale of temperature, there is two common points. There is two common points. There is two common point. The first one is upper fixed point. Upper fixed point. So in bracket you can take down, it's a boiling point. Boiling point of the water. The next one is the lower fixed point, LFP, lower fixed point. In bracket you can take down, it's a melting point of ice, melting point of ice slash freezing point of water, melting point of ice slash freezing point of water. Next point, for every scale, for every scale, for every scale, the number of divisions are different. The number of divisions are different. The number of divisions are different. For Celsius it is 100, for Fahrenheit it is 180, and Kelvin it is 100. Division is nothing but like upper fixed point minus lower fixed point we are talking. Okay. So Celsius 100, Fahrenheit 180, and Kelvin 100. Right on next point. We can convert the temperature from one scale to, we can convert the temperature from one scale to another scale. One scale to another scale. So if you want Celsius, or if you want Kelvin, or if you want Fahrenheit, okay, take that point first, like T, the thing we want, like either T is nothing but Celsius, Fahrenheit or Kelvin, minus the lower fixed point by upper fixed point minus lower fixed point is always constant, is always constant. So if we want, listen, if you want to convert now, so Celsius to Kelvin or Celsius to Fahrenheit, whatever it is, I will take a Celsius minus lower fixed point of the Celsius by upper fixed point of the Celsius minus lower fixed point of the Celsius should be equals to, if I want Kelvin, Kelvin minus lower fixed point of Kelvin by upper fixed point of Kelvin minus lower fixed point of Kelvin. If I want Fahrenheit, similarly I can write like this. Okay. Now the lower fixed point of the Celsius is nothing but 0 and upper fixed point is 100. Okay. And C minus 0 by 100 minus 0 should be equals to, so if I want Fahrenheit na, F minus it is 32 by 232 minus 212, I guess, yes, 212 minus 32. Okay, write down. So if I subtract 212 minus 32, will I get 180? Will I get 100 minus 0, 100? The divisions are I am getting. So similarly for Kelvin, no. So it is K minus 373.15, I mean 273.15 by 373.15 minus 273.15. So only remember this equation enough to convert from degree like Celsius to Fahrenheit or Fahrenheit to Celsius or Celsius to Kelvin, Kelvin to Celsius. So in this lesson, no, like usually we'll talk temperature in terms of theta or else T. We'll talk the change in temperature in terms of delta theta or delta T, both are same. So write down the equation. Oxygen boils at minus 183 degrees Celsius, minus 183 degrees Celsius. Then find same in Fahrenheit. Then find same in Fahrenheit. Clear? The question is clear. Second question is find the temperature which is same in degree Celsius and Fahrenheit. Degree Celsius and Fahrenheit. Okay. Try this question now. Two questions. If they have given a temperature in Celsius, keep that in C. If they are asking F, I need to consider only these two equations, then find F. Take this equation, only these two equations. They have given the value of C there, which is nothing but minus 183. Substitute that value there and get the answer of F. Now the second question, what they have given? Both F and C are equal at which point? Either you can take C in terms of F or F in terms of C. Whatever you want, you can take it. Second question, they are asking what is the common point of F and C, like Celsius and Fahrenheit. So either consider C in terms of F. So F minus 0 by 100 minus 0, F minus 32 by 212 minus 32. Or else this one C or this also C. Then find the value. So what is the answer? Second one, minus 40. What about the first one? Raghav? 361.4. Completed? What is the answer? 25. 25. Okay, what about second one? Minus 40. Plus 180. Second one. First one. Second one? Got the answer? What is the answer? 260 minus 260. 3.33. Second one? So what is the question given? First question? Okay, minus 180 3 by 100. Correct, na? Should be equals to f minus 5 times 9 times. Correct? So minus 183 into 9 by 5 plus 32 should be equals to f. Correct? So if no one is getting, try this one. Okay, if okay, fine. What about the second one? Equation is c minus 0 by 100 minus 0 should be equals to f minus 32 by 212 minus 32. I told that both are equal, no? So either consider, I'll take c is equals to f is equals to x. So x minus 100 by 100 should be equals to x minus 32 by 180. 5 times 9 times, and this is cross multiply. 9x will be equals to 5x minus 160. Correct, no? 32 10 times 320. If it is divided by 2, 5 times 160. So 9x minus 5x equals to minus 160. 4x is equals to minus 160. X will be equals to minus 160 by 4, which is nothing but minus 40. So at minus 40 degree, like minus 40, like both Celsius and Fahrenheit scale are equal. Okay. Which one? 9x equals to 5x minus 160. So if I take this 5x this side, minus 5x. So 9x minus 5x is 4x. So this is 160 minus 160 as it is. So if I take this for this side, no, so 1 times and 4 times, so minus 40. Okay. So as we discussed, the scale divisions, no, Celsius having a division of 100, Fahrenheit 180, what about Kelvin? 100. Since Celsius and Kelvin both are having equal division, no, can I say like 1 division in Celsius is equals to 1 division in Kelvin? Yes, no. Since both are having equal division, like this is my scale 100 degree Celsius and this is 0 degree Celsius, and this is my 373.15 Kelvin, 273.15 Kelvin. So if I talk about the difference, no, this also 100 and this also 100 only, no, the difference 373 minus 273, 100, 100 minus 0, 100. So since both are having a equal division, I can say 1 division in degree Celsius equals to 1 division in Kelvin. Okay. Now the question arrives here. They are they are telling that change in temperature by 10 degrees Celsius, change in temperature to 10 degrees Celsius. Getting the point? Temperature, change in temperature by 10 degree, change in temperature to 10 degree. What is the difference between them? Like I told, 2 words, like change in temperature by 10 degree, change in temperature by 10 degree in the sense like plus 10 degree. Then what about change in temperature to 10 degree? Then both will be equal, no? Whatever you are telling, both will be equal, no? If you decrease, both will decrease. If you increase, both will increase. Then both are equal. No. Then we can say sum and difference. Okay. Like MPC people are there, no? One question. 1 to 50, 1 between 50. Like 1 to 50, between 1 to 50. What is the meaning? From 1 to 50, between 1 to 50. What is the meaning? Huh? 1 and 50 are included. Then between. Okay. The same concept here also. I have told that change in temperature by 10 degrees Celsius, change in temperature to 10 degrees Celsius, or 10 degree, that's it, not Celsius, I will include, like 10 degree for both cases. See, by is nothing but like the difference we are talking. 2 is nothing but like suppose change in temperature Celsius and this is Kelvin. So here 10 degrees Celsius will be equals to 10 degree 10 Kelvin. Okay, for by, okay. For 2 it is not equal, only 2 difference. Okay, 2 difference you know it, like if they mention from both are equal. If they mention 2, both are not equal. Okay. In question, if they mention from, both temperatures are equal. If they mention 2, both temperatures are not equal. Okay. Know this difference. By 10 degree, change in temperature by 10 degree. So under this you can write this one, and change in temperature to 10 degree. Now listen. So the upper fixed point and lower fixed point is there, no? If I subtract the things, I'll get the same divisions here, right? No? Suppose if they mention that 50 degree Celsius and 60 degree Celsius, for example, like upper fixed is 60 and lower fixed point is 50. If I subtract, how much I'll get? 10. Similarly, like whatever temperature we are taking in Kelvin, for example 303 and 293, if I get the difference, what I'll get? 10. Yes, no? Temperature can be anything in both the cases, but the difference I am getting, no? The difference will be equal. That is by. From in the sense like not from, it's to in the sense like for example 50 or 60 if I take, if I add 10 degree Celsius, what happens? I'll get either 60 or 70. But 273 or 283 or 293, whatever temperature Kelvin I am taking, if I add 10, what happens there? 283. Is 60 and 283 are equal? 60 and 283 are equal. So this is the difference between to and from. Okay? ఇంకా ఎవరికైనా అర్థం అవ్వట్లేదు ఇంకా? Write down note point. Note points. Okay, listen. So what is the equation between Celsius and Fahrenheit? C by 100 equals to F minus 32 by, okay. So under the note point, no, the first point, okay. So C by 5 equals to F minus 32 by 9. So can I write this one as F by 9 minus 32 by 9 into 5? I have taken this 5 to the other side. So which is nothing but 5 by 9F minus 32 into 5 by 9 is equals to C. Is this looking like Y mx C? So Y is equals to mx minus C, not plus C. The constant is minus no here, so it is minus C. So the graph between the Fahrenheit and Celsius is minus 17.7 and this is 32. Okay, take down. If you divide 32 into 5 by 9, you will get minus 17.7. So degree is Celsius and this Fahrenheit. Completed? Completed? Take down the graph. completed. So the next thing is, what is the relation between Celsius and the Kelvin? C by 100 is equals to K minus 273.15 by again 100, no? So 100 will get cancelled. C will be equals to K minus 273.15. So I can write K will be equals to C plus 273.15. Okay. So this is in terms of y is equals to mx minus c, and this is in terms of y is equals to mx plus c. Okay. So in this, for this graph will be looking like, this is K and this is C. So interception is 273. So 273.15. So it will be starting like this. This is the graph. First one is solid expansion and the second one is fluid expansion. So under solid expansion we are going to talk about three different types of expansion: linear expansion, areal expansion, volume expansion. So linear expansion, it's one dimension; areal expansion, 2 dimension; volume expansion, 3 dimension. Okay. Now write the first subheading: linear expansion. Linear expansion. Okay. Okay, listen. So if I consider a rod of length L, okay, so it is of a initial length L. If I increase the temperature, what happens? It will expand. Delta L. Yes or no? If I increase the temperature, obviously the expansion will increases. So can I say delta L is directly proportional to the change in temperature? How much our temperature increase, that much our expansion it happens. Okay. If I have 1 centimeter rod or if I have 10 centimeter rod, which will expand more? 10 centimeter rod, no? So can I say delta L is directly proportional to L also? Delta L, expansion is depends upon temperature, expansion is depends upon the original length also. Any doubt here? I'll explain one more thing. Like one more time I explain here. Like rod I have taken of length L. We are talking about a linear expansion. It is one dimensional expansion, no? So if I increase the temperature, what happens? Expansion increases, right? Na? So expansion is directly proportional to temperature, right? If temperature increased, expansion also increases. It depends upon the length also, no? If I consider 1 centimeter or 10 centimeter, like 10 centimeter will expand more like compared to 1 centimeter. So can I combine both of them? Delta L is directly proportional to the length as well as change in temperature. To remove the proportionality, we are adding a constant called alpha. So alpha is nothing but coefficient of linear expansion. Coefficient of linear expansion. So only one thing, if temperature increases, expansion increases. If original length is more, expansion also will be more. So this is coefficient of linear expansion. So similarly, if I talk about area, no, so delta A is directly proportional to delta T. Since delta L is directly proportional to delta T, then I can say A also directly proportional to T, no. Similarly, delta A is directly proportional to A. If I combine both of them, delta A will be directly proportional to A and delta T. So to remove the proportionality, we are adding a constant called beta. So beta is nothing but coefficient of areal expansion. Then delta V is directly proportional to delta T and delta V is directly proportional to V. So delta V will be equals to gamma times V times delta T. So gamma is nothing but coefficient of volume expansion. Volume expansion. And the relation between alpha, beta and gamma is nothing but alpha is to beta is to gamma will be equals to 1 is to 2 is to 3. Okay. So these are the 3 expansion. You can take down. Listen, listen. See, can I take that the initial length as L1 and the expansion happened, so this is L2 or delta L, I will call this one. So delta L. So delta L will be nothing but L1 minus L2. Correct na? So delta L is equals to alpha times L1 into delta T. So L2 minus L1 will be equals to alpha L1 delta T. Correct no? Then what will be the alpha? L2 minus L1 by L1 delta T. This alpha, then beta will be A2 minus A1 by A1 delta T. Then gamma will be equals to V2 minus V1 by V1 delta T. So in some places, instead of delta of density with temperature. Variation of density with temperature. Variation of, I will write variation of density with temperature. So we know that density is nothing but mass by volume, right now? As we increase the temperature, what happens? Delta V also increases, no? Yes or no? If you boil The next topic is applications of thermal expansion. Applications of thermal expansion. Application of thermal expansion. So before that, I'll tell one point. This alpha, beta and gamma is there, no? So alpha, beta, gamma, it depends upon the material. If material changes, alpha, beta, gamma also changes. Okay. Now bimetallic strip. So bimetal, like what is the meaning of bi? Two. So two metals I am taking. So two metal of different alpha or beta or gamma. Okay, I am not considering two equal materials. Two different material I am taking. If I try to increase the temperature, will it expand equally or unequally? ఒక్కొక్కటి ఒక్కొక్కలాగా వెళ్తుందా? See, I told that alpha, beta, gamma depends on the material which we consider. If I change the material, alpha, beta, gamma also changes. So bimetallic strip. Bimetal is nothing but two metals. Okay. So I am considering two different metals of having alpha 1 and alpha 2. Now what I am doing is I am increasing the temperature. Okay, I am increasing the temperature. So if I increase the temperature, will it expand together or one will expand less or one will expand more? And one will expand more. So what happen in that case? It will try to bend. Okay, it will try to bend. So this is my alpha 1, alpha 2. So can I connect like this as a sector, like which is having a, like making an angle theta? Can I take this a whole circle? If I so the formula is, so this is my thickness D. So R will be equals to D by alpha 1 minus alpha 2 times delta T. So this formula will use when alpha 1 is greater than alpha 2. R will be equals to D by alpha 2 minus alpha 1 times delta T. So this formula will use when alpha 2 is greater than alpha 1. So D is nothing but thickness and R is nothing but radius of curvature. Done. So a small which one? Tell. Right now, application 2. Effect on pendulum clock. Effect on pendulum clock. Effect on pendulum clock. So like in oscillation, no, like we used to see the formula T is equals to 2 pi root over L by G. In IP also we have seen this formula, no? Yes. Now in this 2 pi is constant and G is constant, right? Can I say T is directly proportional or equal to root L? Yes, no? So units and dimensions, whenever we are talking about the error, like we are using this formula, no? Delta, let me expand this one, T is equals to L power 1 by 2, then delta T by T will be equals to 1 by 2 times delta L by L. Yes, no? Now expansion, we have learned about the formula delta L is equals to alpha L delta T, linear expansion. So in this delta L by L will be equals to alpha delta T. So can I replace this with alpha delta T? So delta T by T, let me consider this as theta, since I am using this T time period, okay, should be equals to 1 by 2 alpha delta theta. So this is the change in time period of the pendulum clock. In this, T is nothing but time and theta is nothing but temperature. Don't get confused between these two things, okay? Take down. So two different rod of length L1 and L2. Then this one will be having alpha 1, alpha 2. Okay. So change in length is nothing but it is change in length of L1 plus change in length of L2. Okay. So change in length of L1, delta L1 will be equals to alpha L1 delta T, delta L2 will be equals to alpha L2 delta T. So if I substitute the value alpha 1 L1 delta T plus alpha 2 L2 delta T, this is the combination of two rods. So with this we have completed the first topic, that is temperature. So the next topic is heat. So under heat now, like we will talk about the conduction, convection and radiation also. Okay. So we will continue with the next class.